With the introduction of 5G technology, new frequency bands have been made available to telecom operators, such as the so-called C-band. With this, safety concerns make the news. But is it true? Is 5G a safety risk for aviation? To answer that, we have to understand the problem and come down to the facts, evidence and real-world deployments. So what is actually the problem? The problem is primarily related to an aircraft approaching an airport. Onboard instruments, such as the radio altimeter, enable safe landing, for example even in cases of bad weather. These onboard systems are now exposed to potentially interfering signals from the cell towers. The worry is that this interference could be so high that the safety critical instruments no longer work properly. In more details, the 5G cell towers are operating in the C-band according to the rules and requirements. However, it is also common knowledge in the aviation community that the filters currently used in radar altimeters are not very selective. This was never a problem with no signals around their spectrum, and flat and inexpensive filters were more than adequate for their intended function. However, with the introduction of 5G signals in the C-band, this is no longer the case, and interference could cause a radar altimeter to show a false altitude or fail entirely, and this is a safety risk. So, this key question is, depending on the real-world 5G deployments, airports, landing areas, is this interference a reality? And if so, where? What are the influencing factors? Which cells are actually contributing? And so on. To answer these questions, we need fact-based insights. With AirborneRF, we can provide such fact-based insights. How? Well, we start with an airport and have a flight approaching the airport according to the approved 3D landing pattern and corridors. AirborneRF can process all of these details of the flight path, including the characteristics of the aircraft approaching the airport. At the same time, AirborneRF is connecting to all of the relevant 5G network information at the telecom provider, including the detailed configuration of the cell towers, antennas, including even live power settings and other parameters. With this, AirborneRF can compute, forecast, measure and analyze the received 5G signals at the aircraft. In addition to the strongest signal, the software can also analyze all signal contributions from all of the respective 5G cells in the surrounding. This is important because depending on the flight altitude and the network topology around the airport, radio signals can travel quite a long way in the free airspace. By taking all of that into account, AirborneRF can analyze the impact onto the radar altimeter and provide fact-based insights about if and where interference can happen, and consequently, how to avoid it. This is really what we need to mitigate the risk and make decisions based on facts.